Hi, I'm Coach Dalton over here, representing Mathikists. And I've been thinking about triangles a lot lately. I've been thinking about, especially this weird kind of triangle question that the SAT is pretty obsessed with. It's like one of their pet things that they love to test because it's it's totally in their wheelhouse. It's like such like a weird random rule to test. They're able to dress it up in creatively, seemingly complex ways, but it's a super easy thing that makes you feel dumb when you finally realize what they were testing. Classic. They love that. They just can't get enough of that, as we all know. So, and really, it's kind of a trig thing. It's like a sine cosine question. Now, most sine cosine questions can be handled pretty swiftly with SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent, so on, right? Knowledge of SOHCAHTOA will get you through most of the trig sine cosine questions you see on the SAT. Once in a while, I see a question where some familiarity with the unit circle is pretty important, but that's still also pretty basic stuff. SOHCAHTOA unit circle will get you through basically all the sine cosine trig questions on the SAT. Except for this one. Like, there is this one weird type of trig thing that shows up. So if you're on a trig question on the SAT, if you're on a question that involves sine and cosine, but SOHCAHTOA is not cutting it, the unit circle is not enough, you're stumped, I'm almost positive that they're coming up with some way of testing this rule, what we're going to talk about now. So first, what I want to do is talk about just like a classic right triangle here, right? We got a base of 4. We got a hypotenuse of 5. Now, before you all go rushing to the comments to tell me what this side is, which is what? Wait, what is it again? Let's not go there yet. I wanna first just ask you, what's sine of angle x? Like this angle up here. Sine, as we know from SOHCAHTOA, opposite over hypotenuse. So sine opposite side of x is 4. Hypotenuse is 5. That seems okay, right? Opposite over hypotenuse, 4 over 5. Now, tell me what the cosine of the other angle is. Angle y. Now, cosine is adjacent over hypotenuse, right? That's what your best friend SOHCAHTOA says, right? So the adjacent side to this angle, the side touching it, is 4. Over the hypotenuse is 5. So once again, 4 over 5. Now, is that a coincidence that the sine of this angle turns out to be the cosine of this angle? Of course, it's not a coincidence, right? This angle's sine will always be this angle's cosine, because this angle's opposite side is this angle's adjacent side. So there's always going to be that relationship between these two angles in a right triangle. The two angles that aren't the right angle are always going to have this relationship, that sine of one of them is the cosine of the other. And these two other angles also have another relationship that I would like to mention. No matter what the measure of this angle up here is, we know that the sum of these two angles, x and y, is always going to be 90, right? I mean, that makes sense, right? Because all three angles of any triangle add up to 180. We know that this angle is a right angle because I put it there. I told you it's a right triangle. We know it's a right angle. Right angles are 90 degrees. So if this is 90, if all three add up to 180, then these two have to add up to 90. That's fine, right? Okay, so we've laid the groundwork for this rule that they love to test. Now let's talk about that. Sine x equals cosine of 90 minus x. And 90 minus x, this is a way they often refer to the other angle. Because again, if these two angles add up to 90, if we call one of them x, the other one's going to be 90 minus x. So once again, sine of one angle is the cosine of the other. Okay. So we can be a little more general about this and say, in general, in a question, if x plus y equals 90, then we know that sine x equals cosine of y. Or they might test it in the other direction. So if we know that sine x equals cosine of y, then we know that x plus y equals 90. So they find different, ways of testing this rule. Sometimes they'll give you information about the angles, and we must conclude something with the sine and cosine, namely that they're the same. Other times they give us information with the sine and cosine, and from there we conclude that the angles add up to 90. They find different ways of doing it, but my point with all of this is if you're on a weird trig question, if you are on a weird sine cosine question, once again, by weird I mean sine and cosine are involved, but SOHCAHTOA is just not cutting it for you, I'm almost positive they're testing this rule in some way. So investigate that, see if you could find a way this is going on in that question. But even if you can't see it, just assume that this rule is at play in some way. I want you to get more comfortable doing math problems that you don't understand just based on your knowledge of what the SAT is into. So here's what I mean. You're on a weird sine cosine question. You're stumped. You don't know how to do it, but you remember what Coach Dalton said in this video, and you think to yourself, okay, well, I don't really know how to do this, but it's a weird sine cosine question, so it's probably testing this sine x equals cosine of 90 minus x rule in some way. So I'm just going to assume that the two angles add up to 90, and let's see if that helps. Or I'm just going to assume that sine of one angle is the cosine of the other, and see if that helps. And whichever assumption helps me to move forward in the question is the assumption I'm going to go with. And before you know it, you've faked your way through the entire question and gotten an answer. And look, obviously it's cool to get math questions right because you knew how to do them. But I think it's even cooler to get them right without having the full understanding of how everything works in them, just by seeing through SAT BS, I think is a much more it almost feels like we're getting away with a heist or something. But yeah, I'm gonna probably in the next video I'll show some examples of the way they test this rule, so you'll see what I mean. But yeah, I just want to say that if you're on a weird trig question, it's probably testing this rule. So just assume that x plus y is 90, assume the angles add up to 90, or assume that sine of one is the cosine of the other, and you'll be good.